Hello everyone, welcome to another video. We're going to look on case 6, still on transposition of formula that deals with formulae requiring the removal of roots, right? So if you are new to this channel, please remember to like, subscribe, and comment, right? When changing the subject of a formula requiring the removal of a square, it should be noted that taking the square root of a square removes the square. Similarly, when changing the subject of a formula requiring the removal of a cube, it should be noted that taking the cube root of a cube removes the cube, right? And let's look at this from some example. So let's say that you have x squared, right? And you want to remove this square. I'm saying that taking the square root of x squared will remove the square, right? Now let's use indices to show this. So the square root of x squared is the same thing as x squared raised to the power of 1/2, right? And then you apply the power to power rule. So take the power outside to multiply the power inside. So 2 times 1/2, all that will give us is just x raised to the power of 1, which gives us a final answer of just x. So clearly here you can see that the square root removes the square. So in other words, what I am saying is that if you have x squared and you take the square root of x squared, what the square root sign does, it cancel out the square here. That leaves you back with just x. Alright? And the same is true if you have the cube root of x raised to the 3rd power. By applying indices, we can rewrite this problem, and this is the same thing as x raised to the 3rd power, all raised to the power of 1/3. Apply the power to power rule. So if we take 3 to multiply 1/3, all that is going to give us is x raised to the power of 3/3. And then if we simplify that, that's going to give us x to the power of 1, or just x. In short, the cube root of x to the 3rd power, this cube root sign will cancel out the power. That leaves you back with just x, right? So what we're going to do is to use this principle to solve some examples. So let's look at some example now. Example number 1, transpose the formula v equal pi r squared h to make r the subject of the formula, right? So we are given v is equal to pi r squared h, right? And we are asked to manipulate this to make r the subject of the formula. So what we do, we look at the letters around r squared. We note that pi is multiplying r squared and h is also multiplying r squared. So in order to transfer pi h to the other side of the formula, we need to do the opposite. So one way of doing that is to divide both sides by pi h. So we're going to divide this side by pi h, and we're also going to divide this side by pi h. Now clearly here, pi will cancel out pi, and h in the numerator will cancel out h in the denominator. So on the right, what we're left back with is r squared. And over here, we'll just write back what we have, which is v all over pi h. Now, we don't want r squared to be the subject. We want r to be the subject. So we need to transfer the square to the other side of the formula. How can we transfer the square to the other side of the formula? By taking the square root of both sides. So we're going to take the square root of this side, and we're also going to take the square root of this side. So clearly the square root sign will cancel out the square. All that leaves us back with is just r is going to equal to the square root of v all over by h. Now r is the subject. All we need to do is to just rewrite this statement so that the subject is on the left. So we say therefore r is equal to the square root of v all over pi h. And we're finished. Now to example 2. The formula P equal mg plus mv squared all over r to make v the subject of the formula, right? So we have been given P, right, is equal to mg plus mv squared all over r. I want to make v the subject. Now, when we look at mv squared over r, we notice that mg have been added to it. So we need to transfer mg first to the other side of the formula. How can we transfer mg to the other side of the formula? By subtracting mg from both sides. So what we're going to do, right back what we have, which is p, leave a little space, put back our equal sign, right back our mg plus mv squared all over r, right? Now we're going to show that we're going to transfer mg to the other side by doing the opposite, which is to subtract mg from both sides. We're going to subtract mg from this side as well. Now note here on the right, mg will cancel out minus mg. So what we're left back with on the right hand side is just a fraction, which is mv squared all over r is going to equal to p minus mg. Now, when you look at what is happening to mv squared, we notice that that is being divided by r. So we need to transfer the r to the other side of the equation. So we're going to multiply both sides by r. We're going to multiply this side by r as well. So clearly here, r in the denominator will cancel out r in the numerator. So what we're left back with on the right here is just the numerator, which is mv squared. And over here, we have r times p minus mg. Right? Now, when you look at what is happening to the v square here, v square is being multiplied by m, which means that we need to transfer this m to the other side by doing the opposite, which is to divide both sides by m. Now clearly here, m in the numerator will cancel out m in the denominator. So what that's going to leave you back with is just v squared. And over here, you write back what you have, which is just r times p minus mg all divided by m. Now, we don't want v squared to be the subject. We want v to be the subject. So we need to transfer this square to the other side. And we transfer the square to the other side by taking the square root of both sides. Right? So we're going to take the square root of this side as well. By taking the square root of both sides, note that this square root sign will cancel out the square. That's going to leave us back with just v here. And what we have here, we'll just write back what we have, which is just the square root of r times p minus mg, all of that divided by m. And to finish, we just rewrite the subject on the right. So we'll just say, therefore, v, which is the subject, is equal to the square root of r times p minus mg in bracket, all of that over m. And they are finished. Alright? Now to example number 3. Transpose the formula v equal 4 over 3 pi r cube for r. Right? So we know we want to transpose the formula v is equal to 4 pi r cube all over 3 for r, meaning that we want to make r the subject. So when we look at the numerator, what is happening to the numerator here? The numerator is being divided by 3. So we need to transpose this 3, or transfer this 3 to the other side of the formula, right? How can we do that? By doing the opposite of dividing by 3, which is to multiply both sides by 3. So we're going to multiply this side by 3. And we're going to multiply this side by 3 as well. Now, notice here, 3 in the denominator will cancel out 3 here in the numerator. So what we're left back with here is just the numerator of the fraction, which is just 4 pi r cubed. And over here, 3 times v gives us 3v. Now, when we look at what is happening to r cube is being multiplied by 4 pi, which means that we need to transfer this 4 pi to the other side of the formula by doing the opposite, which is to divide both sides by 4 pi. Now note, 4 pi in the numerator will cancel out 4 pi in the denominator, leaves us back with just r cubed. And over here we write back what we have, which is just 3v all over 4 pi. Now, here we don't want r cubed to be the subject, because as it stands, r cubed is the subject. But we don't want r cubed to be the subject. We want r here to be the subject. So we need to transfer this 3 to the other side of the formula. So we're going to do the opposite of cubing, which is to take the cube root of both sides. Right? We're going to take the cube root of the right hand side, and we're also going to take the cube root of the left hand side. Now the cube root sign will cancel out the 3 here in the power, leaves us back with now r, and we write back what we have here, which is just the cube root of 3v all over 4 pi. So r is now the subject, and all I need to do to wrap up, which is just rewrite this statement, so that the subject is on the left. So you say therefore R is therefore equal to the cube root of 3v all over 4 pi. And you are finished. Now to example 4. We have E, right, is equal to Q over 4 pi R cube. And you are asked to make R the subject, meaning that you want R to equal something. There are several ways to approach this, but one way you can approach this is that you know that the subject cannot be in the denominator, right? So you want the subject to be in the numerator. How can you get the subject to be in the numerator? By doing the opposite, right? So you can multiply both sides by the denominator. So that's what we're going to do. So we're going to take 4 pi R cube to multiply E. And we're also going to take it to multiply the fraction here, which is Q over 4 pi R cube Now, by multiplying both sides by the denominator, you note that 4 pi R cube here in the denominator will cancel 4 pi R cube here in the numerator. So a left bracket on the right hand side is just the numerator of cube. Right? Over here now, what you have is just 4 pi R cube E. Now, remember that the subject that we want is R. So when you look at R cube, what is happening to R cube? R cube is being multiplied by 4, by pi, and also by E. So we can transfer 4 pi E to the other side of the formula by doing the opposite, which is to divide both sides by 4 pi E. Now, by dividing both sides by 4 pi E, you notice that 4 in the numerator will cancel out 4 in the denominator. Pi in the numerator will cancel out pi in the denominator. And E in the numerator will cancel out E in the denominator. So what you left back with on the left is just R cube is going to equal to what you have on the right here, which is just Q all over 4 pi E. After this, you check again. Remember, you don't want R cubed to be the subject. You want R, but as it stands now, R cubed is the subject. So how can you transfer this 3 to the other side of the formula? You can do the opposite, which is to take the cube root of both sides. So we're going to take the cube root of this side, and we're going to take the cube root of this side as well. So the cube root sign will cancel out the power 3 here, leaves you back with just R is going to equal to the cube root of Q all over 4 pi E. And you're finished. Right? So R is now the subject. Now we have a final example over here, which is number 5. We're given T equal W times the square root of R squared minus Y squared. And here we want to make R again the subject. So we want to get R equaling something. Now, what you need to do, what is happening to the square root of R squared minus Y squared? It is being multiplied by W. So in order to transfer this W to the other side, you need to do the opposite, which is to divide both sides by W. We divide this side by W and we divide this side by W. Clearly here, w in the numerator will cancel out w in the denominator. So what we have left on the right is just the square root of r squared minus y squared. And over here, we end up with a fraction, which is just t over w. Now, here, we need to get rid of the square root sign. How can we get rid of the square root sign? By doing the opposite, which is to square both sides. So we're going to square this side. We're also going to square this side. Right? By squaring both sides here, the square on the outside here takes out the square root sign. So what we're left back with on the right hand side is just r squared minus y squared. And on the right, all we have is t over w all squared, right? Now, here, what is happening to r squared? We're subtracting y, right? So we can y squared, sorry. So we can transfer this y squared to the other side of the formula by adding y squared to both sides, right? So we're going to add y squared to both sides. So it's going to be t over w all squared plus y squared is equal to r squared minus y squared plus y squared. And clearly here, you can see that minus y squared plus y squared, that is just 0. So what you're left back with here is just r squared, right? And here, you still will just write back what you have here, which is just t over w all squared plus y squared. Now remember, as it stands here, r squared is the subject, but you want r to be the subject. So how can you transfer this square to the other side? By taking the square root. So you can take the square root of this side, and you take the square root of this side as well. So the square root sign will take out the square. That leaves you back with just r. And on this side, you write back what you have, which is just the square root of t over w all squared plus y squared. And you're finished. I'm out of space, but r here is the subject. So your final statement, you will just rewrite r on the left hand side. Alright, so that's it. Thank you for watching, and do enjoy the rest of your day.